I think I'm live. Let me share my screen with you all. Okay, I think my screen is visible. Let me recheck. You are given a zero indexed integer array nums consisting of 3 into n elements. You have to remove any subsequence elements of size exactly n from nums, remaining two equal parts. Uh, sum is sum of first, sum of second. Difference is sums of the two parts is denoted as sum first minus sum second. 3, 2, difference is 1. 2, 3 minus 1. Okay, minimum difference. Let's suppose I removed 3. Okay, so I will have the element as sums of 0 is equal to 3. The array will be 1, 2. The difference in sums of the two parts will be 2. If you remove nums of 1, 3, 2, difference will be this. Okay, in this example, 7958, this I have to minimize the sum. Okay, I have to remove a subsequence of size n. What is the value of n? 1, 2, 3, 4, 5, 6. So I have to remove two elements, right? So to remove two elements, see, I have to make something like uh, the minimum. The minimum, see, I have to find the minimum minimum difference, right? So that means I have to do something like left side should be minimum. We have to maximize the left side, and we have to minimize the left side and maximize the right side, right? N is equal to 2, so we must remove two elements and divide the remaining array into two parts containing two elements each. If you remove nums of 2 is equal to 5 and 5 and 8, that will not be the case. We have to remove acha. Okay, he is removing 9 and 1. Okay. Okay. Me right. Let me do just try run of some examples. In the first example, what was the question? 312. I have removed 3 uh, parts. Says 1 second. Let me read it. Here num has 3 elements, so n is equal to 1. I have to remove one element. If you remove nums of 0 is equal to 3, the array will be 1 comma 2. The difference of this sum with two parts will be minus 1. If you remove nums of 1, acha, okay, that's the same thing. Okay, let's suppose the array is 5, 4, 2, 11, 6, 3, 9. Okay, let's suppose 1, 2, 3, 4, 5, 6, 7. One more element. Um, let's write 7 and let's say 1. Okay, this is the array. Let me write it here also rather than doing this here. Let me just write it here. 1 comma 5 comma 4 2 11 6 3 9 7. I'm going to take my time. Okay, so how many elements are there? 1 2 3 4 5 6 7 8 9. Okay, I have total of 9 elements here, right? I have total of 9 elements, so I have to remove 3 elements. I have to remove 3 elements, correct? In this question, he have removed the maximum one and the minimum one. Okay, how I will know which elements I have to remove so that the sum will be maximized? Sorry, sum will be difference will be minimized. I'm sorry. 11. Suppose I remove 11. Okay, I remove 11, 1, and 9. Suppose I remove these three. Okay, what is going to be the array? 5, 4, 2, 6, 3, 7. Okay, now 6, 3, 7. If you want to minimize it, I have to divide the array into two equal parts. Now let's sort this array. 7, 6, 5, 4, 3, 2. One element from here, one element from here. Okay, 7 comma 2, 6 comma 3. 5, 4. 5 to 7, 14. 6 for 10, 13. The difference is 1. Let me see if I am right or wrong. Just a second. Okay. Let's return 0 for now. Minus 20. Expected is minus 20, not 1. Okay, okay. This approach that I am thinking of, it is not going to work. I have to minimize. So the minimum should be greatest. That's the main thing now. Okay. I will keep 11. I, if I'll remove, suppose I'm removing, no, the order subsequence order should be same. Okay, order should be same. That is also the one thing that I have to keep it in mind. Okay, so how about 5, 6, 7? So 7, 6, 5 in the same. 7 to the 14 plus 5, 14 plus 4, 18. That's the thing now. In right side I have to in right side I have to maximize. In left side I have to minimize. So if 4, 2, 3 and 5, 6, 7 on right hand side, I have to remove some elements. So I have to minimize left side. Suppose I will write it as 1, 2, 3 left side and maximize right side. So it is going to be 11, 6 and 11, 7 and 9. Let's think. 11, 9, 7. Okay. 11, 9, 20, 27, 6. Yeah. Still it is coming 1. So I think the approach that I'm thinking of, this should work. Let's see. What I'm thinking. See, I have to maximize the right, like to get the maximum difference. I have to minimize the left side and maximize the right side. Okay. So the main question is how I'm going to like maximize the like keep the maximum sum at the right hand side. Okay, that's the main thing that we are focusing on. Okay, let's think. I have to keep left and left to be minimized, right to be maximized. So keeping the sum, can I use like, because I will can I use prefix sum of calculating all the sum? No, no. uh, Minimum sum and maximum sum, can I use something like heap? Because prefix sum, I don't know it is going to work or not. Let's see. Okay. uh, if I'll start from the left hand side, I'll go from left to right. Okay. uh, I will have to keep a prefix sum to just keep adding the elements in the maximum heap until I'll have n elements. After that, I can check if I can improve the current n element sum by replacing largest element. Okay. So I think I'm visible. Yeah. One second, let me recheck. Yeah, I think I'm live. Okay, let me write the code that I'm thinking of. No, the first thing is I'll keep uh, two mm, uh, two arrays, the prefix sum and the suffix sum. Okay, and n is equal to nums dot size prefix of n comma 1e 15 comma suffix n comma 1e 15. Okay. Long. Let's write it later on. I have to initialize a priority queue for minimum and priority queue for maximum, right? Priority queue for the minimum elements and the maximum elements. Minimum elements and maximum elements. Okay. This is going to be for the mm, right sum. Okay. Okay. This time I'm going to make for the left one, so it is going to be minimum priority queue, right? Okay. Left sum, or what was written in the question? Sum first, sum second. Let's write it sum second. No, sum second, sum first. Great. Now what? I got my two sum. Now uh, I'll just have to see. What I'll do is I'll just check the sum for the first n elements. After that, I'll keep checking. If I'll get the sum which is greater, I'll just replace it. Okay. Okay, first of all, I'll just push back uh, some second that push, and here I have to write long nums of I. Okay, long. Okay, sum is equal to 0. This way I got the sum for the first n elements. Now I have to add it to our prefix sum, right? Prefix of n by 3. Okay, n by 3 minus 1 is equal to sum. I got that. Now what? Now I'll have to check for the remaining elements, right? Okay, so for and I is equal to not 0, I is equal to n by 3, I is smaller than 2 into n, 2 into n by 3. Great. 2 into n by 3 I plus plus if uh, the second dot top, if it is greater than the element, if this is the case, sum is equal to pq dot top. Okay, nums of I. Some second at top. Great. Now, after popping, what I will do? Just push it. Great. I have to also change it to like end long, right? Okay, great. Now, after doing this, I'll again have to update the prefix part. Prefix of I is equal to sum. Great. Now, after updating this I have to do the same thing uh, for the suffix part, right? Okay. So sum is equal to 0 for and I is equal to n minus 1 equal to 2 into n by 3 I minus minus. Okay. Now just uh, sum first dot push sum nums of I. Sum first dot push nums of I added to the sum plus is equal to nums of I. Great. Now what? Now suffix of 2 into n by 3 minus 1 is equal to sum. Is equal to sum. Okay. Now I got the suffix thing. Now what? Do the same thing. And I is equal to 2 into n by 3. I is equal to 2 into 3 minus 1. I is greater than or equal to 1. I minus minus. Now what? Same if sum first dot top, if it is smaller than nums of I. This is the case. Sum minus is equal to uh, sum first dot top, sum plus is equal to nums of I, sum first dot pop. Okay. Now sum first dot push long nums of I. Great. After getting out of this, sum first of nahi, suffix of I is nothing but value of sum. Now I got my suffix, I got my prefix, I got both of them. Now I have to just keep it in mind, like how I'm going to get my answer, right? So I started updating it from how it is going to look like. 1 second. Updating my okay. For int I is equal to n by 3 minus 1, I is smaller than 2 into n by 3 I plus plus. Okay. Now what? The main thing. If the value of answer is greater than the prefix of I minus suffix of I plus 1, if this is the case, just write answer is equal to nothing but prefix of I minus suffix of I plus 1. Okay. return answer. That's it. Okay, I haven't initialized answer, right? Long answer is equal to 0. Also, here it is going to be I is smaller than I plus 1 is smaller than n. Okay, and this, there may be some compilation errors. Let me just run this code and see. Okay, there is a compilation error. Expected this. For this, I think this is just missing. Wrong answer. Expected one. Okay, no issues. Let me recheck this code. I made a prefix sum. I made a suffix sum. Gave all of them as 1e15. Okay. Made a priority queue to keep track of the second sum. Made a priority queue to keep track of the first sum, which is going to be greater, like smallest. Okay. Sum is equal to this. Started from 0. Go until n by 3. I plus plus. Second push long nums of I. Okay. Plus nums of I. Minus 1 sum. And I is equal to n by 3. I is smaller than 2 into n by 3 I plus plus. If some second dot top is greater than nums of I, mm, if some second cut top is greater than nums of I, first of all I have to remove this, right? Sum minus is equal to sum dot top. Let's see now if it is working or not. Nah, not now also. Push this. Uh, Sum minus is equal to this. Sum plus is equal to nums of I. Some second dot top. Push long nums of I. Is equal to sum. Again, sum is equal to do the same thing for this one. Greater than 2 into n by 3. Greater than equal to into n by 3. I minus minus. Suffix sum dot push. Long nums of I. Sum plus is equal to long nums of I. Okay. Suffix of 2 into n by 2 into n by 3 is equal to sum point I is equal to 2 into n by 3. Let me try run this code where it is not working. Just a second. For suffix one, I'm starting from the uh, where was I? Huh? Here now. Okay. For suffix one, let me calculate for from 2 into n by 3 to I greater than equal to 1. I greater than equal to 1. I don't have to calculate everything. I just have to calculate till n by 3. Okay, I greater than or equal to n by 3. Okay. Okay, no issues. uh, Top smaller than some minus is equal to this minus some first dot top plus is equal to nums of I, some first dot top but first dot push nums of I. Great. Okay, but why this is not working? That's the main thing. Try run this code again and see where it is not working. So I'll just make a suffix sum and a prefix sum. Okay. Suppose the array is same 1 5 4 2 11 6 3 4 7. Start from this element, go till this element 1 5. Okay. 1 5 4 2 11 6 3 4 7. If I'll make a subarray subsequence 1 plus 5 plus 4 plus 2 5 4 9 10 12 12. Okay. For this I'm live or not? I'm live now. If I'm not, there is no meaning doing this. Yeah, I am live. I made this. Okay. This till this it is completely right. Long answer is equal to 0. For and I is equal to this. I, how is 0 going to be greater than? Okay. I think now it should work because it is not going into this loop. That's why it is not working. Yeah. It is working completely fine now. I made a mistake. That's it. Now let's submit the code and see if it is working or not. Yeah, it accepted. So Talking about time and space complexity, time complexity is not nothing much, just n into 3, and space complexity is more like 2n, maybe, yeah, 2n, and for priority queue it is making some other space. So space complexity is more, but time complexity is not much. So I think this is one solution that I can think of. There may be another solutions. Let's just see if those solutions, let's just take an idea of those solutions. If the editorial is present, requirement of n into 2n, let's see the code part. Okay, okay, I'll see it later on. So thank you so much for watching. It accepted. Yeah.